the polar coordinates, Airy's stress function. So just like Cartesian coordinates, you have in polar coordinates also the function phi, but here it is a function of r and theta. Instead of x and y, it is r and theta, polar coordinates, one linear and one angular. So the biharmonic equation in this case, biharmonic equation is once again it is same, del power 4 phi is equal to 0, same thing. But here del power 4, which is the operator, this is given by, I will give you, there it was allenittadu del power 4 dou power 4 x dou power 4 by dou x power 4 ಆ ಥರ ಇತ್ತಲ್ವಾ, ಪ್ಲಸ್ 2 dou ಸ್ಕ್ವೇರ್ ಬೈ dou x ಸ್ಕ್ವೇರ್ dou y ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ dou power 4 by dou y power 4 ಇತ್ತು. ಇಲ್ಲಿ ಆ ಥರ ಅಲ್ಲ, instead of that you have here in terms of r and theta you have the operator, biharmonic operator like this. This is dou power 4, or I can write this as like this, dou square of del square of del square. So del power 4 can be written like this. Here del square is nothing but dou square by dou r square plus 1 by r into dou by dou r plus 1 by r square into dou by dou theta square. So here this can be written as like this, del square by del square like this. So two times like that also you can write. So phi will be there. Same thing will come here. Dou square phi by dou r square plus 1 by r into dou phi by dou r plus 1 by r square into dou phi by dou square phi by square. The denominator, it has got power 2. Numerator also will be having power 2. See here, dou square pi by dou r square, dou square pi by dou theta square. Here also dou square pi by dou r square, dou square pi by dou theta square. Only here pi is there, r is there. So numerator power is 1 means denominator power is also 1. So these two are same. You can see that distances they are same. This can be written like this. These two are same. So first thing you have to take second derivative with respect to r. Second term you have to take only first derivative with respect to r along with 1 by r. Third term 1 by r square will be the second derivative with respect to this. So the equation is this should be equal to this is the biharmonic equation. If it satisfies biharmonic equation, if phi satisfies biharmonic equation, then it is the stress function. Now in this also we will have three stress components. Once phi satisfies biharmonic equation, which is a stress function, and once it is a stress function, we can find out the stress components. Here the stress components are sigma r, sigma theta, over theta. First one is called as the radial stress. Second one is the circumferential stress. Third one is the shear stress. Sigma is called as radial stress. All these I have explained in that video. Radial stress, this is circumferential or hook stress. Circumferential stress, this is shear stress or tangential stress. The formula to find these stresses, we have to remember Sigma r is given by 1 by r into dou phi by dou r. 1 by r into dou phi by dou r. And in r is in r is money. You stick on to one relation. Okay. I have written r like this. 1 by r into dou phi by dou r plus 1 by r square into dou square phi by dou theta square. So this you have to remember. This gives sigma radius stress. Circumferential stress is given by dou square phi by dou r square. That's it. Only one way. And shear stress is given by 1 by r square dou phi by dou theta. 1 by r square dou phi by dou theta minus 1 by r into dou square phi by dou r dou theta. So these are the expressions used to find the stress components. So please note that. For this I have told in earlier video. If this is r direction, this will be theta direction. Okay? Radial direction, circumferential direction, and if you take a plane, if you take an element here, this I had explained in another video. So if you take an area like this, r will be acting like this, sigma will be acting like this, sigma theta will be like this, 2r theta will be like this. So this is the radial stress along the radius direction, circumferential stress along the circumferential direction, shear stress parallel to the area of the element. This is how they act. Whereas in the case of Cartesian coordinates, you have sigma x, sigma y, dou x, y. So in Cartesian coordinates, it will be like this. Because I have explained, I am going to take the element like this. Sigma x will be like this. Sigma y will be like this. Dou x will be like this. This is in two-dimensional Cartesian. This is two-dimensional cylindrical. That is polar. There is a difference. In Cartesian coordinates, we use x and y. In polar coordinates, we use r and theta. So these three formulae you should remember to find the stress components in polar coordinates. So you should know how to differentiate partially, that's all. Partial differentiation ಗೊತ್ತಿರಬೇಕಷ್ಟೇ, ಬೇರೆ ಏನಿಲ್ಲ. So one problem already I have done in video 23. Another problem I am going to do. ಅರ್ಥ ಇದು? Yes, now we will take it. So I will take the problem such that already phi is a stress function. That means you need not prove this. It is already satisfied. That is the meaning. First step is satisfied. Again, it takes a lot of time to do this. If they ask you to prove, then they have to give 20 months for that. So normally they have not asked that, but in Cartesian coordinates they can give. Yes, I will take up the problem now. Given the stress function means already the stress function. We need not prove that. phi is equal to, given the stress function, phi is equal to minus p by pi r theta sin theta. See, minus p by pi r theta sin theta. So this is the stress function. Evaluate the stress components at the point 1 comma pi by 2. At the point 1 comma pi by 2. So 1 comma pi by 2 means r is equal to 1, theta is equal to pi by 2. That is it. Here instead of x and y, we have r and theta. Solution. So directly you have to use the formula to find the stress components. This is formula. Okay. We need this formula. So to use this formula, how many derivatives we need? Can you tell me? You just see this and tell me how many derivatives we require, or shared derivatives. How many? See all the three. Total how many derivatives we need? ಮಾತಾಡಬೇಕು ಎಷ್ಟಿದೆ ಎಷ್ಟಿದೆ how many derivatives are there here? First expression ಎಷ್ಟಿದೆ 1 2 ಇಲ್ಲಿ 3 4 5 ಕರೆಕ್ಟಾ 5 derivatives. You calculate those 5 derivatives and then substitute here, that's all. So first this is 5 minus p by pi r theta. So please note that p is a constant. Of course, pi is also a constant. P, pi are constants. Unless it is given, you have to take p as constant. Only variables are r and theta. Variables are r and theta. So first we will differentiate with respect to r. So let us find out this first. In the same, write down these three formulae. Then first we find out dou phi by dou r. If you are differentiating phi with respect to r, theta should be taken as constant. Correct? So differentiate this. So theta sin theta becomes constant. This is another constant. So minus p by pi. Theta sin theta is constant. Derivative of r is 1, correct? R के differentiation है 1 with respect to r 1. Now I need the second derivative also, correct? Dou square phi by dou r square also I need. Right, dou square phi by dou r square. Once again differentiate this with respect to r, you will get 0. Take a 0 because it doesn't contain any r term. All the terms are constant. Okay. Is that answer? This term. Next, I want with respect to theta. So I will write here dou phi by dou theta. You be careful. You should be careful here. You have to differentiate with respect to theta. When you are differentiating with respect to theta, r is constant. So you have a constant like that minus p by pi into r. That becomes constant. So minus PR by pi is a constant. So we have to differentiate theta sin theta. Product rule use ಮಾಡಬೇಕು. Derivative of product rule ಏನಿರುತ್ತೆ? Derivative of first function into derivative of second. First function is theta, second function is sin theta. U into v. U into derivative of second plus v into derivative of first with respect to theta. So theta into sin theta differentiation of cos theta plus second function sin theta, the differentiation of theta is 1. We are differentiating with respect to theta, it is 1. So this is the answer. Next what you have to do, this we have to differentiate once again. Is it done? Dou square pi by dou theta square by. Yes, product rule bante. So here also this is a constant. See, minus PR by pi is a constant. Written as it is. Into, ಇಲ್ಲಿ ನೋಡಿ ಈಗ theta into cos theta. Once again you have to use product rule. So theta into cos theta is minus sin theta plus cos theta into theta is 1. That's all. Plus derivative of sin theta is cos theta. Sin theta into 1 sin theta, right? So cos theta. This is the answer. Now that means we simplify this. Minus PR by pi into minus theta sin theta plus 2. Correct? Correct or what? So allegation, so we got this also now. We got this also. Last one, dou square pi by dou r dou theta. That can be obtained from this or from this. We have now dou phi by dou r is equal to minus t by pi theta sin theta. So I will differentiate this with respect to theta now. Dou square phi by dou r dou theta. I have to differentiate with respect to theta there. Minus t by pi is constant into I have to differentiate this now with respect to theta once again using product rule. So theta into derivative of sin theta is cos theta plus sin theta into derivative of theta is cos theta. So these are the, so we got this one. So we got all the 5 derivatives. Now we have to substitute all these. So this one, second one, dou phi by dou theta is third one, and this is fourth one, this is fifth one. So one by one we will substitute, and then we will simplify. You will get the stress component. So first stress component is sigma r. So let me find out sigma r first. Write down the formula, substitute those derivatives there. So now the stress components are number 1 sigma r radial stress 1 by r, write down the formula, into dou phi by dou r plus 1 by r square into dou square phi by dou theta square. Write down the formula. I want the stress component at the point what? 1, 5 by. If they give this point, you substitute for r theta. Otherwise, simply if they give find the stress components, just you substitute in this and leave it. That's all. Simplify and leave it. If they give the value, you have to substitute those values. R is equal to 1, theta is equal to 5. Now substitute now. So first I will write the expressions 1 by r into what is dou phi by dou r? This one. This I have to put. Minus t by pi. Be careful with sigma, the signs. Minus t by pi theta sin theta. That is this. Plus 1 by r square into dou square phi by dou theta square is this. It is minus pr. Be careful about the signs, plus minus signs. This minus pr by pi into, one more into is there, minus theta sin theta plus 2 cos theta. Yes, this is the expression. Now, let us see this minus comes to outside. Minus t by r pi theta sin theta. Let us simplify the brackets. So this becomes, see, this into this into 1 by r square. That means it is minus to minus becomes plus 1 by r square into pr means 1 r will vanish. R pi will be there. Here p will be there. Theta sin theta. This is what you have to do. So plus 1 by r pi p theta sin theta. Correct? P will be there here. Theta sin theta will be there. Next. Minus into plus minus 1 by r square into p by pr by pi into 2 cos theta. That is the expression we get. So minus, I can write this as once again here 1 r another r will get cancelled 1 by p by r by P by R phi will be there into 2 cos theta. Do it carefully. That's what we get. We will cancel it. Which one will we cancel? See? Which term will get cancelled? First and second cancel it. But this is also theta sin theta. This is also theta sin theta. It's equals to minus. So we have this minus P by R pi 2P by R pi into cos theta. Now we can put R is equal to 1. After simplifying it, we can put minus 2P by 1 into cos. What is cos pi by 2? Cos pi by 2 value cos 90. Cos 90 is 1. 0. Sin 91. Cos 90. 0. So sigma R value 0. Whatever value you get, you will just write it. At that point it is 0. Suppose if theta is pi by 4, how is 0? If theta is pi by 4, then cos pi by 4. Here cos pi by 2 is 0, therefore this becomes 0. So there is no radial stress. Next, second element, we have to find sigma theta. Second component is sigma theta. So I will write second sigma theta. What is the formula? Dou square pi by dou square. Dou square pi by dou square. Only one term. What is dou square by dou square? It is 0. We have got 0 here. At all the points, it is 0. So in this problem, no stress in the radial direction, no stress in the tangential direction. Next, third one. Illa 0 banduttalla. Dou square by dou square. Here itself it is 0. Overall it is 0. Whatever value of r and theta is there, it is completely 0. More than 0, tau theta. Tau theta is equal to shear stress or tangential stress 1 by r square into dou pi by dou theta minus 1 by r into dou square pi by dou r. Substitute for it. First to substitute in that. You have dou pi by dou r. Dou pi by dou theta is this. Then dou square pi by dou r dou theta is this. Substitute both of them. Let us take what we are going to get. 1 by r square into what is dou pi by dou theta? This one. Minus pr by pi into theta cos theta plus sin. Okay. Minus 1 by r into dou square pi by dou r dou theta is this. Minus p by pi into theta cos theta plus sin. Yes. We have to simplify that now. First you simplify that, then put r is equal to 1, theta is equal to pi by 2 and get the answer. So fill here, once again here you have to multiply, 1 r will get cancelled, you will be getting minus p by r pi into theta cos theta, minus into plus is minus once again, p by r pi, same thing. Here minus into minus becomes plus, p by r pi, theta cos theta, then plus p by r pi. Here also, if any term gets cancels, it just cancel it. All put 0 agutte. Idu cancel. Both of them will get cancelled. See? Correct idea? Is it correct? All are 0. Andre idenayithe ella 0 banduttalla. All 0. So all the three At that point, so you got sigma, so at the point 1 comma pi by 2, sigma theta all are stress free level, stress free point. There is no stress at that point. But some point may not have any stress at all. But at this point it is stress free. If they give some different point, ಈಗ theta pi by 4 ಅಥವಾ pi ಕೊಟ್ಟರೆ then it is not stress free. So there will be some value of stress there. So in this case we have got all the 3 stress components equal to 0. That means radial stress, circumferential stress and the shear stress, all of them are equal to 0. That means the body is subjected to no stress at the point 1 comma pi by 2. Got it? So like this, they may give any function of phi. Here I have taken minus p by pi r theta sin theta as the function phi. One more I have done p by pi into r theta cos theta I have done in that class 23. You refer that class 23. One more problem I have done. So both these two problems you just go through and practice. One of them may appear in the exam. So 10 marks is okay. This carries 10 marks. So both you have to learn Airy stress function, Cartesian coordinates, 2-dimensional as well as polar coordinates. So if they give you Cartesian coordinates, they may not give you polar coordinates. Any one problem you can expect and it is easy. In Cartesian coordinates, 2 steps are there. First step, you have to prove del power 4 phi is equal to 0. Second step, you have to find the stress components. In polar coordinates, I have not proved that. Already it is a stress function as given. So only stress components we have found out.